I'm going to show you how to solve an exponential equation that sort of becomes a quadratic or has a hidden quadratic in it. Now, a question like this to me seems more like a math puzzle than a real math problem. I don't see where a problem like this would arise in nature, perhaps solving some very particular kind of differential equation. But anyhow, we'll solve this anyways. These questions are in your book. So have a look at this here. If I was to simply take the log of both sides, it wouldn't really get me very far, because I'd have the log of a difference of terms, and I don't really have a way of splitting that apart to ultimately end up figuring out what x is. So the key to solving a problem that looks like this is in noticing that there is a hidden quadratic. I'm just going to rearrange things slightly. You know that 2 times x is the same as x times 2. So I'm going to write it like that. 7 to the x times 2 minus 3 times 7 to the x minus 18 is equal to 0. And if I look at this closely and consider my laws of exponents, if you have the product of exponents, that's the same thing as taking the power 7 to the x and raising it to the exponent 2. So I can rewrite this as 7 to the x squared minus 3 times 7 to the x minus 18 equals 0. Now, if you look very closely at this, you will see a quadratic emerge. You see here, I'm just going to draw a box around it. I've got 7 to the x, and here I've got 7 to the x. Over here it's being squared, over here it's not. So I can imagine I'm trying to solve a quadratic, and what my solution is going to give me is not x, but it's going to give me 7 to the exponent x. So in viewing this as a quadratic, I now have to find two numbers that multiply to negative 18 and add to negative 3. And those numbers are going to be negative 6 and positive 3. So I've got 7 to the x. You see, 7 to the x is taking the place of where normally we just have x as our variable in solving a quadratic. And my numbers that add to negative 3 are negative 6 and positive 3. And that pair of numbers also multiply to negative 18. So that becomes our solution. So see how I wrote that in red? Just imagine 7 to the x as a single variable. If doing these bothers you, you can do a substitution. So a little substitution you could do is say let a take the place of, define a as 7 to the x. So then you would have, that would be a, that would be a. So you would have a minus 6 and a plus 3. Just like the quadratics you did. If you're learning to solve these exponentials, it's just like the quadratic you would have done a couple of years ago. Okay. Once we're here, this splits into two solutions. Either 7 to the x minus 6 is equal to 0, or 7 to the x plus 3 is equal to 0, just as a quadratic splits into two. So 7 to the x is 6, or 7 to the x is negative 3. One of these answers is good, and one of them is not. Can you see which one works and which one doesn't? What does 7 to the x look like? If I was to plot 7 to the x, it would look like this. It would look like 2 to the x or 10 to the x, except it would be steeper than 2 to the x, not as steep as 10 to the x. For what x value is my height 6? Answer is somewhere over here. Somewhere over here, there's an x value that corresponds with a height of 6. For what x value is my height negative 3? So when is my height down here at negative 3? And the answer is, it never is. So this side corresponds with no solution. However, this side certainly corresponds with a solution, and we can find it by taking the log of both sides. So I've got the log of 7 to the x is equal to the log of 6. I'm going to use the power rule for exponents to bring that x down. And I'm going to end up with x is equal to the log of 6 over the log of 7. And my solution is 0.92. You can verify that this works by plugging that into the original equation. 0.92. So I've got, let's just give that a try. So 7 to the 2 times 0.92 minus 3 times 7 to the 0.92 minus 18. So this is our check. So I'm checking to verify if 0.92 works. So I've got 7 to the exponent 2. Let me just back up. 7 to the exponent 2 times 0.92. I'm using brackets to get the product of those two to turn it into my exponent. Minus 3 times 7 to the exponent 0.92. And then minus 18. And that's going to give me 0. I mean, it gives me 0.08 because of a rounding issue. Our exponent's not actually, our x value is not actually 0.92. I rounded to get that. So the more decimals you drag around, the closer that gets, but essentially that is equal to 0, verifying that that solves the problem. Okay, so to recap, we have an exponential equation, but from it emerged a quadratic equation. And we notice that by using our law of exponents here, where if you have an exponent that's the product of two numbers, you can make one of those factors an exponent, and the rest of it becomes the base of that exponent. So 7 to the x was the base of a power that was 7 to the x to the exponent 2. So I then notice that 7 to the x kind of looks like a variable in a quadratic equation. So we solve it using the usual quadratic means, but remember that's not giving you x, that's giving you 7 to the x. And then once you've solved that under the usual quadratic means, you can then determine what value of x works. One thing to watch out for is if your power becomes a negative, then there's no solution, because all you need to do is look at the exponential curve to realize that a negative number is not in the range. So we only take the positive one. And the easiest way to solve these from this point is just simply take the log of both sides.